The moon's orbit around Earth appears constant, as civilizations have based calendars on its movements for millennia. However, our satellite is slowly moving away from us. Will Earth eventually lose its moon? This is the Fudge Network, and in this episode, you will learn about the relationship between Earth and the moon, and whether Earth could ever lose its beloved satellite. Scientists have determined the rate at which the moon is moving away from Earth using reflector panels that NASA placed on the satellite during the Apollo missions. For over 50 years, researchers have been directing laser beams from Earth onto these mirrors and measuring how long it takes for the reflected pulses to be detected. Using the speed of light, scientists have calculated that the moon is moving away from Earth at a rate of about 1.5 inches per year. This rate may seem negligible, but over millions of years, it adds up. In fact, scientists estimate that about 4.5 billion years ago, the moon was much closer to Earth and the length of a day was only about 5 hours long. As the moon moves further away, the length of a day on Earth gradually increases. However, the rate at which the moon is moving away from Earth is not constant. It varies slightly due to various factors such as tidal friction, changes in the Earth's rotation, and the distribution of mass within the Earth. Scientists continue to study these factors in order to refine their understanding of the moon's movement. In addition to the reflector panels, other methods are also used to study the moon's movement and its relationship with Earth. For example, spacecraft such as the Lunar Reconnaissance Orbiter have been used to create detailed maps of the moon's surface and measure its gravitational field. These measurements can provide valuable information about the moon's interior and its history. Studying the moon's movement and its relationship with Earth is not only important for understanding the history and evolution of the Earth-Moon system, but it also has practical applications. For example, knowledge of the moon's movement can help scientists predict and prepare for natural disasters such as earthquakes and tsunamis. It can also help in planning future space missions, as the moon's gravity can be used to assist spacecraft in their journeys through the solar system. But why is it moving away? It's due to the gravitational influence exerted by both Earth and the moon. The moon's gravitational pull affects Earth's oceans, resulting in tides. Earth's gravity, in turn, creates similar tidal effects on the moon, giving the satellite a slightly oval shape. Earth's surface also undergoes slight deformation due to the tidal forces of the moon. The part of Earth facing the moon is stretched toward the satellite, and it is this gravitational force that acts on the moon, accelerating it and moving it away. This phenomenon is called tidal acceleration, and it's the reason why the moon is slowly but steadily drifting away from Earth. Over millions of years, the moon's distance from Earth has increased by thousands of miles. This may not seem like a significant change, but it has had a profound effect on the way our planet behaves. As the moon moves further away, its gravitational pull on Earth decreases, causing the tides to become less powerful. In fact, scientists predict that in a few billion years, the moon will be far enough away that its tidal effects on Earth will be negligible. This means that future generations will not experience the same dramatic tides that we do today. On the other hand, the moon's increasing distance has also had an impact on the length of our day. As the moon moves further away, it slows down Earth's rotation, causing our days to become longer. In fact, the length of a day on Earth has increased by about 1.7 milliseconds over the past century. Interestingly, the gravitational pull of the moon, as it causes friction against Earth's oceans, slows down the planet's rotation. About 4.5 billion years ago, when the moon was just forming, the speed of Earth's rotation was much higher. However, these same forces cause the moon to move even farther away from Earth. As the moon moves away from Earth, its orbital period increases. This means that it takes longer for the moon to complete one orbit around the Earth. In fact, the moon's orbital period has been increasing by about 1.4 milliseconds per century. This may not seem like a significant change, but over millions of years, it can have a big impact on the Earth-Moon system. For example, it could cause changes in the tilt of the Earth's axis, which would have major effects on the planet's climate. The moon's movement away from Earth is a natural process that has been happening since the formation of the moon. Over billions of years, the moon will continue to move farther and farther away from Earth, until eventually its orbit stabilizes at a distance of about 239,000 miles from the Earth. So, when will the moon disappear? The idea of the moon disappearing from the night sky may seem unsettling, as it has been a constant companion of Earth for as long as life has existed on our planet. However, the truth is that the moon has been moving away from Earth since its formation around 4.5 billion years ago. Despite the fact that the moon is moving away from Earth, it will not disappear completely from our view. Even when its orbit stabilizes in approximately 50 billion years, it will still be visible in the night sky. However, it will appear smaller and less bright than it does now. This is because the moon's distance from Earth directly affects its apparent size and brightness. When the moon is closer to Earth, it appears larger and brighter, while when it is farther away, it appears smaller and less bright. In conclusion, the moon will not disappear from Earth, but rather it will continue to move away from our planet over time. Its influence on Earth's tides and shape will gradually decrease, but it will still be visible in the night sky for billions of years to come. Ultimately, the fate of the moon and Earth will be determined by the evolution of the sun, which is set to become a red giant in around 5 billion years, engulfing both our planet and its natural satellite. What do you think about all of this? Isn't it fascinating to contemplate the long-term destiny of our planet and its natural satellite, with the knowledge that ultimately, the fate of the moon and Earth lies in the hands of the sun? If you found the video interesting, don't forget to like and subscribe to the channel. Click the bell icon to stay updated on new videos, and feel free to leave your comments below.